Hello and welcome.
I'm the best fingerer of any.
In this lecture, we're going to learn about objects and how we can use functionality on objects and their data to start creating interesting programs. Let's dive in. So let's start off this lecture by introducing something like in a game, you might have an adventurer. He is an object in your world, and he might have some data that represents what he is. Things like his experience points, for example, or maybe his level. He's a level 2 adventurer. Things like that are the data that make up an adventurer. But that's not all an adventurer is. An adventurer is also some functionality, such as the ability to fire arrows, such as being able to jump, and so on. There are other things that can be objects, though. For example, we can represent things in the real world in the computer, such as the player, and we could store relevant properties to the player. Things like, is the player using a controller? Is the player number 1 or number 2? Those kinds of pieces of data. And the relevant functionalities, such as get their current input. Are they holding down the spacebar, for example? Get the skill level of the player. And then you can have completely abstract objects, things like a list. So you could have a list that has the items 1, 2, 3, 4 in it, or maybe it could have any items that you like in it. The data could change, but it might also have some functionality, such as remove the last item from the list or add to the end of the list. So you can see objects are very, very flexible. They can be used to represent myriad different things. And you'll notice that the functionality at the bottom of these objects is actually what those nodes are, or what a lot of nodes are in Blueprint. So
do this one.
hello and welcome. In this lecture, we're going to be enabling physics simulation within our scene so that we can get cubes to move around and things to float as if they were in 0G. Let's dive in and see how this works. So this game is going to be one of physics interaction with objects.
Minimal default. I don't have a minimal default. I think it's just where it has leakage. I think.
Bumping into each other and creating mess and chaos. Let's have a look at how we can do this sort of thing in Unreal. Let's go over to the Minimal Default Level Editor tab. And what we're going to do is, by default, none of these objects will actually be affected by physical laws. So if I take this chair, select it and bring it up in the air, and then I go ahead and hit play, it just hangs there as if gravity was not a thing. The reason for this is that it is expensive for your CPU to simulate physics. So if it doesn't have to, Unreal will not do it for any object in the scene. So we need to go ahead and enable it explicitly. So make sure that the chair is still selected, and then let's drag out the details pane so we can see this a little bit better. Now, at the top of the details pane is a list of things called components. We don't have to worry about this too much. Just make sure the topmost item is selected.
What am I looking for? I'm looking for details. Which is not on here. Here. Window tab. Details. This looks about right.
And then below the search bar, you can see that there are properties, and below the search bar there's actually a list of filters. There's general, actor, LOD, MISC, and physics. I'd like you to select physics so that we're seeing only the actor's properties relating to physics. And you'll see that there is a checkbox here labeled Simulate Physics, and it's currently set to false. If you check that box and hit play, then we get the chair dropping and simulating physics there. Now we can also do this with objects that we add in. So I could go to the Quickly Add button in the toolbar, go to Shapes and Cube, and drag a cube in just under the chair. And in fact, I'm going to bring this above the chair and select Simulate Physics for that cube. If I hit play, then you can see the cube lands on top of the chair and they interact with each other as well as interacting with other objects in the scene. Now there are a couple of other physical properties worth noting here. One of them is the Enable Gravity checkbox. So if I took this chair and the one with physics enabled and disabled gravity, then hit play, you can see the chair just floats as if there were no gravity, whereas the cube still falls as if it has a normal amount of gravity. And then the other property I just want you to take note of is the mass. This is how much something weighs, essentially how many kilograms of substance there is there. By default, this is calculated for you, but you can check the checkbox there to give it a mass that you want. So you can make something super heavy or super light. So if I make the chair super heavy, you can see it reacts a lot less to the cube falling onto it, and it moves much more slowly and sluggishly. So I'd like to challenge you to knock the lamp off the table using the physics system. So enable physics for both the lamp and the table for this to work. Place a large object over the table, presumably with gravity enabled, and knock it over. Pause the video and have a go.
Oh snap. Shift. Delete. We'll cone this, baby. Hey, bruh. The cone at, though. Alright, we want... Damn near perfect. We can make this a little bit smaller. Physics. Gravity's good. Darn! Mass is gonna be a lot heavier. Why does this move just right out the jump? Mass, please. Mass will be real heavy. Bye. Nailed it.
Okay, welcome back. So, I can actually use the cube that I've already got to try and knock this over. So I'm going to move the chair so that the cube hopefully lands down onto the table. Then I'm going to select the table and the lamp on it. I can do that with a shift click to select both, and I can change the details of both at the same time. So I can go ahead and enable physics by clicking the simulate physics checkbox and hit play. Let's see if this works. It landed on the table, but it didn't quite knock it over. So I'm going to make that a bit of a heavier cube by selecting the cube and overriding its mass with the checkbox and setting the mass to 1000 as well. Let's hit that. So heavier mass meant that the statue just went flying off the table when it was hit. That's all for this lecture. I will see you in the next one.
Easy peasy, lemon squeezy.
Hello and welcome. In this lecture, we're going to learn about objects and how we can use functionality on objects and their data to start creating interesting programs. Let's dive in. So let's start off this lecture by introducing a new concept, the concept of objects. It's absolutely vital to a lot of programming languages. So an object is essentially something that you want to represent, a thing. Something like in a game, you might have an adventurer. He is an object in your world, and he might have some data that represents what he is. Things like his experience points, for example, or maybe his level. He's a level 2 adventurer. Things like that are the data that make up an adventurer. But that's not all an adventurer is. An adventurer is also some functionality, such as the ability to fire arrows, such as being able to jump, and so on. There are other things that can be objects, though. For example, we can represent things in the real world in the computer, such as the player, and we could store relevant properties to the player. Things like, is the player using a controller? Is the player number 1 or number 2? Those kinds of pieces of data. And the relevant functionalities, such as get their current input. Are they holding down the spacebar, for example? Get the skill level of the player. And then you can have completely abstract objects, things like a list. So you could have a list that has the items 1, 2, 3, 4 in it, or maybe it could have any items that you like in it. The data could change, but it might also have some functionality, such as remove the last item from the list or add to the end of the list. So you can see objects are very, very flexible. They can be used to represent myriad different things. And you'll notice that the functionality at the bottom of these objects is actually what those nodes are, or what a lot of nodes are in Blueprint. So they start to get a little bit of a mapping between the objects and the functionality. Okay, so we've introduced a bunch of new concepts there. Let's just recap slightly. So we've said that objects are collections of data and functionality. What we may have not realized is that actors are actually objects. Actors are objects that can go in a level, and you can see this if you go into your level, you select
Pause.
the cube, you can see that there's a whole bunch of, in the details pane, a load of data. And as we will see in a bit, there's a load of functionality in the node form in Blueprint as well. Then there are components. Now, components we haven't gone into detail before, but here they are. They are objects that can go on an actor. Whereas actors go on the level, components go on an actor itself. So with the cube selected, you can see at the top of the details pane that there is this static mesh component. If you actually click on that, you will see that the details pane gets a restricted set of details. It shows you not all of the properties.
Wait, rewind that.
If you actually click on that, you will see that the details pane gets a restricted set of details. It shows you not all of the properties that are available on the cube actor, but only the subset of properties that belong to the static mesh component, which is basically the component responsible for telling us how to draw a cube. Now, these objects can often have a lot more data than this, and that means that they can become quite heavy to manipulate by your computer, and certainly if it has to copy these objects around. So instead of doing that, we use a clever structure called a reference, which is essentially just an address, or where do I go to find this object in the computer's memory, so that I don't have to be moving the object around all the time. We'll cover a little bit more about how this actually works in memory when we get to C++, but for now, it's enough to know that it's just an address. So what we can do, for example, let's dive into Unreal. If we were in our main level and we wanted to use some functionality on our cube, then what I can do is I can select the cube in the scene, and then I can go over to my level blueprint and right click, and then I can click a create.
Hold the phone. Double click on the corresponding blueprint asset. This should be a blueprint, no? Built data. You're joshing me right meow. Or 23.
Hello and welcome. In this lecture, we're going to be setting up a new project and learning how to open up the Level Blueprint editor. Let's dive in. So a new section means a new project. Let's go ahead and open Unreal and get to the project browser like there. There is a button in the bottom left called the content drawer. I'd like you to click that and it opens out this drawer, which is essentially just a file browser for that content folder. And you can see we can open up the starter content folder, and under there we can find the maps. And the maps are the levels that we've got in this game. So currently open is the minimal default level, which you can see in the tab in the top left. But you can open any of these other ones by double-clicking on them. They're the ones that I've got a little yellow line. Those are the maps. I'm going to open up the starter map, and you'll notice that your CPU might start its fans going because it needs to prepare the materials that are available in this scene. But if you have a look around, you can see that there's a bunch of different materials of different types as they start to populate, like sandstone, slate. You might want to use these for materials in your finished game. Just have a little look around. And you could do the same thing with the advanced lighting level. Let's just open it up for completeness sake. This isn't as useful as it's more of a demo of how to do advanced lighting, and this is the Epic Games parking lot. So let's open up the content drawer again and go back to our minimal default map. And what I want to show you is how we can get to the blueprints that lie behind this map or this level. What you do is you go to the toolbar where there are a bunch of boxes connected up by little wires, and you click that drop down and then click Open Level Blueprint. What this is going to do is open up a new window with a new editor view. The main thing that we're interested in here is this central area called the event graph. This is where we're going to write our blueprints, and you can close down any of the tabs, the My Blueprint tab, the Details tab that's going to distract us. We don't need those just yet. We can always get them back by resetting our layouts. And what we can do, just to get a bit of a preview of how much functionality is under the hood here, we right click in the event graph. You can see there's a massive long list of just the headings of the functionality. You can expand this out with different headings within headings, and these are all bits of functionality that has been created for us by Unreal that we can just drop in and plug in and use from Blueprint. And now we've got these two windows open here, we may want to just have
There we go. Gravy. We are gravy.
Now, these objects can often have it's enough to our main level, and we wanted to use some functionality on our cube. Then what I can do is I can select the cube in the scene, and then I can go over to my level blueprint and right click, and then I can click a create reference to cube, and this creates a new and then I can use some functionality on our cube. Then what I can do is I can select the cube in the scene, and then I can go over to my level blueprint and right click, and then I can click a create reference to cube, and this creates a new node. Now what's that doing? Well, that's basically telling us this is the cube's address. If you want to do something with the cube, here's where you find it. What happens in Blueprint when you run the game is it's going to go and find that cube, and then you can ask questions or use functionality on the cube, such as saying, hey, where does your static mesh component live? And he goes, oh, okay, the static mesh component's over there. So we go and find the static mesh component, and then we can ask questions of that, and it can say, hey, what's your name, static mesh component? And the static mesh component can say, hey, my name's Bob. And so that is how we can use these references and use the functionality of multiple different objects to get to where we want to go. Now, we've said that a reference is where to find an object, and now something else that's worth pointing out is a data pin. What is a data pin? Well, this cube reference actually has one. This little blue round thing on its right-hand side is a data pin. We've actually seen these before on the print string nodes. They're on the left-hand side and they're purple. And how are these different to the other types of pins that we've seen, these white pins? Well, the data pin is the input or output of data for a node. So a node, if it's on the left-hand side, it's the input, it's the data that node can work with. If it's on the right-hand side, it's the data that node produces. So in the case of the cube, this node produces a reference to the cube actor. Then the execution pins. These are actually what those white pins are really called to differentiate them from the data pins, and they are still when to run the node. So data pins are what to run the node with, execution pins are when to run it. So with all that information, let's do a little bit of using the functionality of these objects. So we've got our cube reference. If we drag off of the cube reference pin, you can use all of the functionality that that cube has. As I said, we've got a component on the cube called a static mesh component, and I want to go ahead and get hold of a reference to that. So we'll look for get static mesh component, and the bottommost item for me is get static mesh component. I can click on that. We get a new node with the input being our cube reference and the output being a reference to its static mesh component. So if we drag off of that, then we can ask for the functionality of the static mesh component, such as get display name. And that gets us the input of the static mesh component reference, and it uses its functionality of get display name, and then it returns a string or a text value that we can print using the print string node. So we can drag off of that and type print string, and then we can hook up the execution node so that that runs after the other two print strings at begin play. You'll notice that some of these nodes don't have execution pins. That might be confusing. When do they get run? Well, they get run whenever Blueprints thinks it's appropriate, essentially whenever it's needed by a node that does have an execution pin. So if we go ahead and hit play, you can see that it pops up with the name cube static mesh component 0. A string or a text value that we can print using the print string node. So we can drag off of that and type print string, and then we can hook up the execution node so that that runs after the other two print strings at begin play. You'll notice that some of these nodes don't have execution pins. That might be confusing. When do they get run? Well, they get run whenever Blueprints thinks it's appropriate, essentially whenever it's needed by a node that does have an execution pin. So if we go ahead and hit play, you can see that it pops up with the name cube static mesh component 0, something like that. It's a bit programmery. It's not Bob. It's a bit more involved than that. But you can see we've essentially coded in that chain of questions that I had on my slide. So I'd like to challenge you to go ahead and get the mass of our static mesh component. We have configured it in the past. If you go into the level and have a look at the details pane, you can see that one of the physics property was the mass, and we've configured that as a piece of data on the static mesh component. Well, if you delete the get display name node and drag off the static mesh component, you should be able to search for get mass, and that should get you the piece of data on the static mesh component. And see if you can print that value using our print string node. Pause the video and have a go.
There. And delete that connection. What's this? Gotcha. What is the mass of the cube? 1777. It's 0, brother. Clear that. Okay. Appreciate it.
Okay, welcome back. So if we go back to the blueprint, delete our display name, drag off the static mesh component and search for get mass.
Okay.
Then we can pull in that node. We've got a return value here, and that's going to be our mass value. You can see if you hover over it, it says returns the mass of this component in kilograms. And by the way, return value just means the output data. And then we can drag that node into our in string for the print string. And you see it creates a little conversion node. That's okay. It's converting from whatever this value is into something that the print string will accept. We can go ahead and hit play, and you see we get the value of 1000, which we know was the mass we configured, or whatever.
All right, let's just change this. Fine. That ain't working, huh? Alright, whatever. I'm not gonna troubleshoot that right now.
You actually do configure, you can change that and see that this value will change as well. So that's it for this lecture. We've learned about objects and their references and how to use functionality nodes in Blueprint.
Nice.
Hello and welcome. In this lecture, we're going to be using those functionality nodes to manipulate the object in our scene on request. So if I hit a spacebar, I can make this cube bunny hop up and down.
That's pretty cool. doom. Doom, doom, doom. What is Prime Gaming? Hog Galaxy? This arc is free already, I think.